Okay, so I have started up the recording. Okay, so yeah, so we were on AAA topic. So AAA stands for authentication, authorization, and accounting. Okay, so to achieve these three features on a Cisco platform, we had something called Cisco ACS servers. It used to be a package which we used to deploy on a VM or on a Windows machine. Now, this is no more, this has been obsolete from the market. Cisco has released another product called as Cisco ICE. Okay, so Cisco ICE is not only capable of providing AAA, but it is also capable of providing lot many other features. Okay, it has the templates, it has the monitoring tool where it can see what is the consumption happening, all in a graphical interface. Okay, whereas Cisco ACS server used to be the simplified version. It used to collect the accountings, whoever did the configurations or whatever the session recorded the commands, so those were all recorded on the ACS boxes. Okay, and rest of the things like authentication and authorization was also one of the feature that ACS was providing. But in the case of ICE is completely a brand new product, and it has lot many options. Okay, it can do the work of monitoring, it has the AAA features, it can log the session, and there are a lot of scope and development. It has the bring your own device management. Okay, so all about your wireless uh, analyzes, like which user is connected to what. You can set the policy for them, so you can do lot of many things here which you were not able to do on ice the on ACS server. In my lab, what I do is I just take one of the appliance from GNS3. Okay, and the package, the GNS appliance already has a package for TechAS Plus and a Radius server. So what are these two things? These are the two protocol which is taking the AAA packets. So how is AAA connected? So let's say if this is a core layer which connects to internet, core is connected to distribution, distribution is connected to access layer, and access layer is connected to the user or the end host. Okay, now let's say if one needs to take SSH of one of the box, so the packet will travel like this. Okay, so let's say the SSH is gonna travel this way. Now there are two ways. You can either have the manual username and password for this particular user. Okay, for this particular user XYZ configured on all of the boxes. You have XYZ, you have XYZ. Now this is not a feasible solution when you have devices like 5,000 in number. Now you cannot go and manually configure them. So the best practice is keep a AAA server. Okay, and configure those user instead of on multiple devices, just configure them on one centralized AAA server. So what happens is when you're taking a SSH, your device, your Cisco box is not gonna do self authenticated. Instead, it's gonna send the packet to the AAA server, and this communication is happening over on two protocols, either on TechAS or Radius. Okay, whichever your company or organization is preferring, you don't need both, it is either one of them. Okay, and AAA is gonna authenticate, authorize, and it's gonna say yes, he is a legitimate user, allow him the access, and then you get the SSH console. Okay, so this is the whole concept behind AAA server. In the last class, we also checked what is the difference between TechAS and Radius. If I quickly write it now, TechAS is TCP, this is UDP, Radius is UDP. TechAS is Cisco proprietary, Radius is open source. TechAS is gonna encrypt the entire packet. Okay, the entire packet. Whereas Radius is gonna encrypt only password, nothing else. What is the port number here? It's 49. Whereas over in the Radius, it's it has multiple port numbers. So for authentication, the latest port number is 1812, but prior to 2000, the year 2000, you had something called as 1645. Okay, before 2000, so they are UDP ports. And for accounting, you have 1813 officially, and unofficially you have 1646. Okay, so the what is a small background behind this. They were unofficially taken 1645, 1646. Once they documented, they could not get these port number because they were being used by different services like data metrics or some other vendors, so they could not get the same uh, port numbers. Okay, so they are on 81812 to 1813. So whenever you configure Radius server, okay, Radius server on a Cisco box, you have to implicitly mention this, because by default they will be considering this. Okay, so I'll show it today while configuring. What else do we have? It's a heavyweight protocol. The reason is it's a TCP which works on three-way handshake, whereas the Radius is gonna be lightweight because there is no there is no three-way. It's a UDP protocol. So TechAS server is mainly used for device administration. Okay, so it's mainly used for device administration. That means when you need all the features enabled: accounting, authorization, and uh, authorization. Okay, authentication, authorization, accounting. So you call it as device administration. Whereas Radius is a best choice if you are only looking for network access. Okay, you have a couple of devices and you just need to set up the authentication or a network access. Then this is the most preferred one, Radius. I was going ahead with some lab, and unfortunately, because of the GNS bug, I was not able to show it. Right? So it was nothing but it was a bug from. So it was a bug from the GNS. Okay, so I just closed my GNS, I restarted, and it's all good. So let me redo that, or I'll just recap whatever I did. So if I go to my first box, or let me do one more thing. Let me close everything and let me start. So this is my user, and user is taking a SSH or a telnet on the first device. Okay, so let's say he is user, he's taking a SSH or a telnet, and we need to see how the TechAS or the Radius is gonna forward the packet, get authenticated, and is gonna tell the computer to yes, that he's the right person to do that. Okay, so let me change the host name. Let me say it's a PC router. Okay, so over here I only have a IP on my interface 1.50. Similar way, if I open up the switch, the network device, I have a IP address 101. Okay, and in the last class I was not able to ping between these two boxes, so let's give a try now, and they are reachable now. Okay, so how do I telnet? So basically I just do a telnet command 192.168.1.101. Okay, admin and Cisco. So I'm good with this. How is it working? Is it on TechAS? Is it on Radius? Is it on a local username password? So let's check the packet here. So if I open up the Wireshark over here, so let's give it a try. If the Cisco box is forwarding any sorts of packet to the AAA server. Okay. So if I redo once again telnet, so I don't see anything. Okay, I don't see anything, so that means there's no communication with the server. So whatever is happening, it's happening only between the PC and the switch. Okay, that's because we have a local username and password set up here. Now that's a challenge, right? I don't want so many times my username and password being set up. I want something to be centralized. Okay, I don't want this local username and password, and that's why I showed you in the previous class how would I make use of the AAA server to bring up those centralized option, right? So let me configure that. So let's say I'm given with the AAA server, and I'm just configuring it. So I'm first gonna enable the AAA model. Okay, so I'm gonna say this is very important command. If you don't enable the AAA features, then the AAA will not work. I'm enabling this. I say AAA group server is a TCAS protocol, which I'm gonna show you first, and then I'll show the Radius server. And any word, okay, just any word which you can remember. And now you need to define some container. Again, that's a word. Okay, so if you say server name question mark, is just something which you have to give inside that. Okay, so I have a container within my main group. Now I have to define what is my TechAS server and what is the key within the container. Okay, so I'm gonna say TechAS server container. What is my address, or what is my AAA server address? It's 192.168 1 dot, I think 150, right? Yeah, it's 150. I'm gonna say 150. What is the key? So I showed you last class. The package includes username GNS3 and password to be GNS3. So I'm gonna give the key to be GNS3. Key is nothing but the password here. Okay, and I'm coming out of this. Now the last thing, or see, whatever I did is just a configuration of TechAS, but it's not been selected as a first preference. Your preference is still happening onto the local username and password. So let's give it a try. Okay, if I go with admin and Cisco, okay, so you can see the communication happening. So let's see why is that happening. That might be because I already have AAA from my last class. See, that's because of this line. This is very important line. Let's say if I take this out and if I give a retry. Okay, if I give a retry with my local username and password, that's gonna work. So that means communication was between the two boxes. Okay, to bring to point to the AAA server, I need to get this command. So what is this command gonna do? It's gonna say the first preference for the credential to be checked is via authenticating with this AAA server. Okay, if this AAA server is not reachable, then prefer the local username and password. So I'm gonna say AAA authentication login default must be this group. If this is not reachable, then local. Okay. And now if I initiate, and if I also keep my Wireshark with me, and if I type admin and Cisco, it will not work. Okay, because the AAA server is up, and as per AAA server, username and password is GNS3. See, it's working. Okay, so this is a wrong word, I guess. So let me fix that. See, it's called as TAC plus. Okay, in case of Wireshark, and you can see they are getting authenticated. And if you see the communication source and destination, you will nowhere see your PC IP or the computer IP. The computer IP was on 192.168.1.1. You will nowhere see that IP because the TCAS protocol is between the Cisco box and the AAA server, not between the user and the Cisco box. So you will not see any IP of your computer. So the computer is initiating the request, the router or the switch is forwarding it to AAA server, getting authenticated, and then sending back to the user saying, yes, you are authenticated and you can do whatever is being allowed to do. Okay. So the second A, authorization, will come effective over here. Okay. Now let me do one more thing. So this was regards to TechAS. Now let me show it for Radius server. So I just take out all these things. What else do I have for TechAS? So I'll take out this so that I can show you from scratch. Okay, fine. Okay, now time to test Radius server. For a normal user, TechAS and Radius is gonna be the same. It's just about the configuration, how you set it up. Okay, so let me do it for Radius now. So as usual, I go to AAA, I go to group, I go to server. Now I'm gonna take it as Radius. Okay, and I'm gonna give some name. So let's say now I prefer GNS3 group 2. Okay, earlier I took GNS3 group 3, or might be GNS3 group something, right? Now I'm taking something else, and over here I'm gonna create some container. So in my earlier case, I made use of container, right? So at this moment, let me say it's container 2. Let me come out of this. Let's configure the IP and the key, okay, for this Radius. So let's say Radius server, and what is the container name? This is the container name. I say Radius IPv4, and where is my AAA hosted? My AAA is hosted on 192.168.1.150. If I do question mark, now these are things which you need to take care of, right? So it says by default it's 1646, but we know that they are unofficial port numbers. Okay, by default, to give the fallback compatibility, Cisco is considering 1646 and 1645, but my AAA server don't need to be running on 1646 and 1645. Might be my AAA is a latest box, might be it's a Cisco ICE box which only understand 1812 and 1813. But my Cisco box might be an older device, and on an older device you will still have the default configured on these port numbers, right? So I need to change the behavior, and I must implicit define that. I am gonna say accounting port now is not 1646. Instead it's gonna be 1813. And similar way, authentication is no more 1645, it's gonna be 1812. Okay, this is one change which you're doing in the case of radius. Okay, so what's the issue? So I have missed something. Okay, so it's one after one. Okay, so first I'm going to do with accounting. I'll re go to the same line, and now I'm gonna make it for authorization port 1812. Okay, so two commands come out of this. Okay, before coming out of this, give the key. It's GNS3 for radius. And if you want to see the radius package, I'll show it to you guys. Where is this radius package created? Okay, so it's cat etc. Okay, so in the case of tech, as I had gone inside this, but in the case of radius, I'll go within free radius. Okay, and let's see what else I have. So I have something called 3.0. So let me go with 3.0. And what else I have? Users. And let's see the package. Okay, so this is the radius package. And what is the username and password the developer has created for radius? He has created the username as Alice, password GNS3. Similar way, he has created one more user called Bob and password as GNS3. So password he has kept GNS3. So I'm gonna make use of GNS3 in my case. Okay, so this is why I said GNS3. So let's come out of it. Let's give a test. Okay, before giving a test, the important command, that's the AAA and preference. Okay, so now let's say who is my most preferable person for authentication, and what is the group name? It's GNS3 group 2, right? This one. And what do you need as a fallback? So you need your local, right? Fine, we are done. So how if I try giving my TechAS for a testing purpose? So if you remember, in the case of TechAS, my username and password used to be GNS3, right? So let me give as GNS3. So it will not work, right? It will not work because for radius the username and password is different. And if you see now, TechAS has stopped, and now I must filter it for radius. And do you see the packets are now for a radius protocol, and also my username and password are just stuck. So that means my username password are not working. Should I try with a local username and password? So let's give a try. If I do admin, okay, and if I try Cisco, let's see if that get authenticated. So the packet has arrived on the AAA server via protocol, radius protocol, but it's gonna say no. Okay, so you can see, and it's okay. Let me, okay, might be the server was not reachable and that's why it took the fallback. Okay, so let me try with the GNS now. So for GNS, it's Alice and GNS3. So you have your radius authentication packet here. Okay, so the thing with this particular Docker is that you first need to see if your radius package is running or not. Now that's again something, a bug with respective uh, to the AAA Docker. Okay, how do I see if the service is running? So I go to AAA. I make use of command service free radius. Let's say start. So you see, it's failed. That means this package is not running the radius or the rightful radius package. So this Docker is of no use for me. That's why you saw the local username and password got authenticated even though you had the radius configured. The reason is radius package is not running. So what is the fix around for this? There's no fix around. You just need to delete this and get a new one from your available list. Okay, so I've been doing this, so I know about this Docker. Okay, so you just get one more out of it and just connect it. Okay, and make sure the service is running. If the service is not running, it's as good as the radius server is down. So I'll edit the configuration first. So this glitch happens only with radius, not with the TechAS. TechAS will be always running perfectly. Only with the case of radius, it automatically goes to failed state sometimes. Okay, so you have to delete and plug a new one. So let's give an IP. It's one. What was the IP that I gave? It was. mm, Okay, it was 150, right? So let's give that 1.150 1.100 save. Okay, and now first thing what I do is I'll check the service. So I don't need this on AAA. First let's go and check if the service is up or not. Service, free radius, and start. Okay, and it says okay. Now that's a good news. Okay, this is my server and everything looks to be good. Now let's give it a try. Okay, because we have all the configuration placed, so I'm not gonna do anything with respective to that. So let's do a telnet and let me make use of admin and admin password to just make sure if the radius is working or not. So basically this should get failed if really my radius is working. Okay, so it worked. Let me once again see what is the package. Okay, package is fine. This is 150. So let's see what is the content of that. So what is the container name? It's okay, it's 1.50. So let's give it a try. Might be it took some time to get settled down. So I'll just give a try once again. So let's give a try with the actual radius username and password, which is Alice and GNS3. Let me ping this server. Okay, so they are not reachable. That's why your local username and password worked. Okay, let me once close this and restart. Let me try to ping the IP. Okay, now it's up. What about this one? Okay, from here it's reachable. 1.50. Okay, this is not on 100, it's 101. Okay, fine. So now we have the reachability, and the radius username password should work. Okay, so if I keep my Wireshark with me, and if I trigger up a telnet, do we see any packets coming? So let's go with Alice and GNS3. Okay, so it went once again to failed state. So this particular Docker is always little messy Docker. So there is no workaround until you just redo once again. So let's give a final try. Let me edit the configuration. One dot 100 and it's 1.101. Okay, sorry, not 100, it's 150 here. And the router is on 105, 101. And let me power on this. Let's ping that. So let it settle down. It takes like 1 to 2 seconds. One 192, 168, 1.101. Okay, it's reachable from this side. Okay, so it's reachable from here as well. Okay, so let me try with radius, telnet, alice, gns3, and it worked. Okay, so it says hello alice. What about my wireshark? So wireshark captured. Okay, and if you see the backend, it's saying that it's requesting the radius. The first packet was a request packet, and the radius accepted that. So it says it's a right username and password, and he's authorized. So that's how the radius work. So you see, the value alice was given, password was authenticated. I told you, in the case of radius, your username, all other things will be unencrypted, whereas only password gets encrypted. So that's why you see password is encrypted format. The rest you can see, the port number, it's 1812, and the source side, the Cisco is preferring 1645. On the destination side, you are having 1812. And this is where the username and password is right, and you got a hello message. Now let's say you give a wrong password. Okay, you purposefully give a wrong password. Let's say admin and admin, and let's see what happens. It got rejected. Okay, so these are the codes that radius server is gonna respond with. Let's give the local username and password, which is admin and Cisco. Okay, let's see what it's gonna do. It's gonna reject it because my AAA radius server is up, so I cannot let the local username and password to be allowed, right? So the right one is Alice or Bob. That's the package says. Okay, so let me try with Bob and GNS3, and yes, that's fine. Okay, so these are the two username that the package consists of, and that's why we get authenticated with these two. Okay, and this protocol are between the AAA server and the Cisco box. It's not to deal with the user point of view. You will not see TechAS or Radius over in this region. It's always between this. Okay, so your first packet will hit to the Cisco box. Cisco box will point it to the server with the help of the protocol, either TechAS or Radius. Okay, and what are the difference between the two, and you all the other things you are good at that. Okay, fine. So I want to do one more topic. It's pretty simple topic. That's ACL. It will not take much time, and I'm gonna give you some. So I'm breaking. Am I audible, or my voice is breaking? So any disturbance with my audio? Okay, so I guess it's all good. Okay. Okay, so the another topic for the day is ACL, which is again a topic under security. Okay, what is ACL? Access list. Why do we need access list? We need access list to block or permit, right? Why do we need access lists in Cisco router and Cisco switch, not in a Cisco firewall? Anyone knows the answer for that? So I'm asking, why do we need access list on a Cisco router or a switch and not on a firewall? Okay, so I don't say that access list not required on firewall, but say let's say we mainly use of access list on router and switch to permit and deny, right? But in the case of firewall, we have a different mechanism how the firewall works. Okay, so access list is actually not really required if you want to focus from the deny point of view. So anyone knows what is a background of this? Why firewall work differently than router and switches? So no one knows the concept of firewall. Yes, firewall is a piece of box which will block everything. Okay, so in the case of firewall, you try to send anything, they by default are gonna be denied. Okay, you need to write permit statement in order to allow something. Okay, so that's how the firewall works. Whereas in the case of router and a switch, everything is allowed by default. Okay, it will just see the routing table and it will forward it. In the case of switch, it will see the MAC address table and it's gonna forward it. So how are you gonna bring those uh, restriction? Let me say it as a restriction. How are you gonna restrict it? So let's say there is a user whom you wanna block it. You don't want it to be forwarded, right? So you need some mechanism with which you can block that. And similar way in a switch, let's say switch is used to connect user 1 to user 2, and you don't want 1 and 2 get communicated, but by default switch is gonna forward it. So how are you gonna block them? So there is where you bring your access list. Okay, in the case of router and switches, to block something or to permit something, you need to have the access list in place, and then you can manipulate or you can play around with the traffic flow. In the case of firewall, by default everything is denied. You just have to write the permit statement wherever you want them. Okay, so by default, what is ACL gonna help us? ACL is gonna help us on packet flow, to bring the restriction to, or I can say, to block unwanted communications, right? So yeah, so these are something. And or I can also say control the router to allow or deny. Okay, so these are the main purpose of ACL: to allow or to deny, to restrict some users. Okay, so types of ACLs. There are two main types of ACLs. One is called as numbered, and the other one is called as named. Similar way, you also have two different of types of access list depending upon the performance or the functionality, and we call it as standard and extended. And similar way over here, we have standard and extended. Okay, so let me write it once again: standard and extended. Okay, so two types of ACLs basis on the categorization, that is named, sorry, that's numbered and named. Okay, and depending upon the functionality, this is again divided into two. One is called as standard and extended, and similar way you have standard and extended. Now how are they different? Okay, so let's say if I write in this way, standard numbered, and similar way its counterpart, that is standard named. Okay, so let's say this is one block. On the other side you have extended numbered, and you have extended named. Okay, so what is the difference, and how are they similar? Okay, so in the case of standard, let me tell what is standard first. Okay, so in the case of standard, the first definition is it's gonna see only the source address. Okay, it's gonna see the source address and then gonna see the statement, the matching statement. If I say is it to permit or to deny, and it's gonna take action. Okay, depending upon my statement. If I say permit, it's gonna allow that. If I say deny, it's gonna deny that. On basis of what? On basis of source address. That means if I have a router, okay, and I have a computer here with 192.168.1.0, let's keep it as 1.1, and over here I have 192.168.1.2. What is standard doing? Standard is blocking. Let's say it's blocking 1.1. So I'll apply it somewhere here. I'll apply the ACL, standard ACL, and I'm gonna deny that. Okay, it's gonna be denied. On what basis is this deny statement happening? It's happening on the basis of source, right? Now what is a problem with this kind of behavior? The problem is all the ports get blocked by default. All the port in the sense, if this server has multiple package within it, like it has HTTP, or it has a DNS, or if it has FTP, or it has a www. Now with the help of standard, if you're trying to deny, all the package are also by default getting denied. Now that's something which you cannot afford, right? You need a better solution where you're blocking 1.1 with respective to 1.2, but not for all the package. Might be you still might be you still need one package to be allowed. Okay, so let's say 1.1 is being blocked, 1.2 with respective to 1.2 for HTTP www, but 1.1 is still permitted to 1.2 on FTP, DNS, HTTP. Now this kind of requirement you cannot achieve with standard, so that's where you have to bring the extended. What is extended gonna do is it works on basis of matching source, destination, service, port. Okay, or I can say the protocols, whether a TCP or UDP. So these are couple of important things which extended is gonna check and then do blocking or allow. Okay, in the case of standard, it's very straightforward. It will only see source and it will block it. Okay, or if it checks the source, and if the statement or the action is to permit, it will permit that. Okay, now that's a drawback, but yes, if you wanna block completely, then this is simplest option to block it for respective to all the port. Okay, but if you're looking for port basis blocking or service basis blocking, then you have to go with extended. How do I identify if an access list is standard or an extended? Okay, so if I see anything numbered between 1 to 99, so that's a example for standard. If I see access list, okay, something like access list, and if they say 150 and it says permit 1.1.1.1, now this number is gonna let you know that it's an example for extended. Okay, so for standard it's 1 to 99. Any number, if you see only 50, then it's an example for standard. Okay, it's in a range of 1 to 99. If you see anything between 100 to 199, then it's an example for extended. Now yes, there is something called as expanded ranges. Okay, so in the case of standard expanded ranges, you have 1300 to 1999, and similar way in the case of extended expanded, you have 2000 to 2699. Okay, so these are the ranges that you use on a access list. On which kind of access list? The numbered access list. Okay, so I told you one type of access list is numbered, and the second type is called as named. Why do I make use of named? Can't I make use of numbered? Both are same. The working nature of numbered and name are the same. The only benefit of having named access lists are it's descriptive. Okay, it's gonna help you understand what is that access list written for. Okay, so let's say you have an access list. Okay, let me give you an example. So let's say this is numbered, where I say access list 100 permit 111.1.1. I have another access list, let's say 67 deny 2.2.2. Do you understand what kind of access list is this written for? On what service is this written for? No, right? In the case of named, usually what we do is we give a descriptive word. So let's say IP access list. Okay, and I can give some name, so something like HTTP block. Okay, and now I will write access list 100 permit 1.1.1 or access list 67 deny 2.2.2. Now while troubleshooting, it's more easier for an engineer to understand what is that access list is all about, right? So I can easily say that this is for a HTTP block, so I'm blocking these two. But if you go on a troubleshooting call with this kind of format, you will take time, lot of time, to understand what are these written for. Is this to block HTTP, or is this to block SSH, or is this to block something else, right? So that's the benefit of keeping named. Functionality wise, both are doing the job what it's meant for. It's only that when you have thousands of line, this is gonna help you to understand what is what. Okay, let's say you are given a task. Okay, you're given a task where you need to add few more IPs to the HTTP block. Okay, you're given a task to add few more IPs to HTTP block. right? If you deal with this kind of environment or this kind of organization, it will take a lot of time for you to find out which access list is defined for blocking http. Okay, and finding it out and then placing them will be taking lot of time. But in the case of organization who are making use of the named format, you can easily look for this keyword and plug this two IPs, or you can write these two IPs over here so that they are within this block. Okay, so that's the difference between named and numbered. Functionality wise, they are the same, and between standard and extended there are a lot of difference. Standard is something which checks the source ip or the source address, and it's gonna perform the action that's meant to do. Whereas in the case of extended, it's gonna check source, destination, service, flag. Okay, the multiple things it's gonna check, and then it's gonna see if it is meant for allow or meant to block them. So that was regards to type of ACLs. Okay, so in Cisco iOS 12.13 onwards, there was a concept released called as sequencing. Okay, so how sequencing helps me? So basically, let's say when I'm writing an access list 100. Okay, and I want to permit the source 1.1.1 to reach 2.2.2.2 on ICMP packet. Okay, similar way I am writing another access list where I say 1.1.1 reaching to 2.2.2 on FTP. Similar way I am writing another access list where I say 1.1.1 reaching to 2.2.2 on DNS. Okay, so let's say this was for permitting, permit, and permit. Okay, but unfortunately, you have a big deny statement over here. So how does a access list work inside a Cisco box like router and switches? They work in a sequential way from top to bottom. As soon as it finds this match, it's gonna do the action, and then it's not gonna go to the next line. So I mean to say, let's say this is a Cisco box. If a packet just enters, what is gonna happen? So it's gonna first hit this ACL. It's gonna say the statement is denied, and I'm gonna get denied. So all the packets get dropped immediately. Okay, that's how ACL works. They are not gonna check all of them simultaneously, or they are not gonna see if they get denied. They are not gonna move to the next line. They do not work like that. It's very straight and forward. Okay, so if it see a deny statement on this number, that means all the beneath these lines are gonna get ignored. I can say it as getting ignored. Okay, so you need to bring this deny statement somewhere here at the end, something like this. You need to get it. Okay, so prior to 12.13, the only option was to delete them and reconfigure them in a sequence so that you have these in the first place and then you have the deny statement. But now the job is easy. Okay, after this 12.13, you have a concept of sequencing. Sequencing is nothing but giving a number. So let's say I give this as 1, I give this as 5, I give this as 10, or this as 15, right? Now this is a sequencing. It's very easier now. If I have to move something, I just take this out, I make it as, okay, I guess I'm audible. So I just make this as no, Okay, I write one more statement for deny, and I put the sequencing which is above this number. So let me put it as 100 and just keep it with me. So I have my first line over here with 5, the sequence number 10, sequence number 15. So all are permitted, and at the end I have sequence number 100. So I can keep some rooms for my future ACL. So I can have 20 left out, 25, 30. So that's how the sequencing is gonna help you. Okay, and the ACL, how it works is it works on top to bottom sequencing. As soon as it finds the match, it's gonna consider that and push it to the outbound interface. And the outbound interface will check once again if there is an ACL, and it will do the rightful job, and it will push it out. Okay. So that's about the ACLs. Now, how is ACL processed? So I'll prefer showing it on the flow chart. Okay. Okay, so let's say this is my flow chart for the ACL. Okay, it's nothing but it's just take this whole thing inside a router or a switch. Okay, let's say there's a packet incoming, or I can write it as inbound traffic, the packet which is entering. Okay, and then it goes within all this flow chart, and then it's ready to go out over outbound interface. So the traffic that's leaving is called as outbound. The traffic that's entering is called as inbound. So what is happening? So as soon as some traffic enters, it will first see if there is an ACL on that particular interface. If there is no ACL, there means there is no possibility of blocking or allowing or something like that, right? You're straight away gonna send it to the permit and then make a route lookup. It will go to the routing table. It will see who is the exiting interface. Okay, it will see if this destination network is a routable or it's a unreachable. So basically it's gonna see the routing table and it will push it to the outbound traffic or the outbound interface, and that interface is gonna see if the packet is routable. If let's say there is no destination found in the rib router information base, okay, it's gonna discard that. Let's say it found the routing, it knows which interface to send. So in that case it's gonna send it to the outbound interface or outbound buffer. We call it as outbound buffer. So again the ACL will be checked on the outside interface. Okay, so when I have a device, the ACL can be on this inbound. ACLs can also be on the outbound direction. Okay, so for inbound, I just said that there was no ACL. It went to the routing information table. From routing information table, it is just checking whether I have a exit path. If there is no exit path, it is going to drop. But if there is an exit path, it's gonna send it to outside interface. And outside interface, it's once again gonna check for ACL. If the ACL is not present, then just permit it. That's all. It's all done. It's ready to be sent out. But what if there was a ACL? If there was a ACL, now it's gonna see if it is for deny or it's for permit, and accordingly it's gonna take it consider them. Okay, if it's for deny, then basically packet will drop there. There's no way of going out. If it's for permit, then the packet will go out. Similar thing happen on the incoming interface. Okay, I took the example when ACL was not present. Okay, and it went to the permit. But if there was an ACL, there will be some condition that has to match. Okay, so whatever traffic is incoming, is this traffic incoming permitted or denied? And basis on this, it's going to routing table. From the routing table, it's going to check the outbound ACLs and then finally moving out of the device. So this is a short ACL operations within the Cisco boxes. Okay, it is checking the ACL on incoming and the outgoing interface every time. Okay, so before uh, so what basically it does is it will check the ACL first, and then it will push to the routing table, and from the routing table it will see who is the exit path, and then it will see once again the routing, whether the ACL is present on the outbound direction or not. Okay, so let me talk from the rules of ACL, which is again very important thing. What are some rules for ACL? Or so on an interface, you can have only one ACL that you can call. Okay, on one protocol and one direction. You cannot have multiple directions. So how many of you know how to write ACLs? So under ACLs there are two steps. The first step is defining the ACL. Defining the ACL is nothing but defining whether to permit or whether to deny, what is the source, what is the destination, what is the service port. So this is called as defining. The second step is called as implementation. Okay, implementation is nothing but on which interface are you gonna call this ACL and on which direction. So let's say you say interface F0/0, you want to call that 100, and on which direction, in or out, incoming or outbound direction. So you have to mention that. So there are two steps for ACL. First, define what is source to destination. Is it for permit or deny? What is the service port? So this is defining them. The second step here is implementation. On which interface are you implementing? So let's say this is my router, this is FA0/0, and this is FA0/1. So I'm gonna define my ACL first. I'm gonna say source is 1.1.1 going towards 2.2.2. So that's my first define criteria. The second thing is it I'm allowing or I'm denying that? That's also important. I'm gonna permit or deny. So I'm gonna mention that. So this is for permit. The third thing is I need to mention if it's for all the services or it's only for TCP 49. So I'm gonna say the service number as well. So these three is my defining. I call it as defining. Now these ACL would have been either as a standard ACL or extended ACL, right? So the numbers are important now. So let's say it was a standard ACL with 10 number, or it was an extended ACL with 150 number. Now this is how I am gonna call it on the interface. I'm gonna say access list, whatever number it's, let's say 10. Okay, and in which direction do you need it? Do you need it on in or out? So that's the second step in the case of ACL. Okay, so it says the first rule number says you can have only one access list. You can have only one access list on one direction on one interface. You cannot have two or three or four, only one. Okay, on a one interface. The access list must have one permit statement at the end, otherwise they are gonna be all denied or implicit denied. Now let me tell you what happened once in our production. So there was an engineer who was writing the ACLs. Okay, so what he did was, before defining something, he straight away went to the interface and he did the second step. The second step was implementation. What happens is when you immediately apply some ACLs, let's say ACL 100 in, by default this empty bracket is gonna consider as denied. So anything which was passing over here is getting denied by default. That's why we say that define what is 100 now. You first have, the first step is to define that 100. You must say 100 is for 1.1.1 to 2.2.2. It's for permit statement, it's for so and so service, so that other traffics are not impacted. Okay, if you don't do this step, the step number one, and you straight away go to step number two and write empty ACL number with ACL 100 in, basically it's gonna be denying everything, all the packets, and that can lead to outage. Okay, so don't do that mistake. Always do first define and then implementation. If you don't, then what's gonna happen? By default everything is gonna deny. So you have to have a permit statement. If you don't include permit statement, then by default it's gonna take, the ACLs are gonna take as deny statement. If a match is found, no more criteria statements are checked. So basically how ACLs works are, so let's say you have 100 of access lists. Okay, 1 2 3 4 5, and on the 100th line. So if there is an incoming traffic and you have an access list, it's gonna first try to match with the first access list. If it matches, it's good, it's going out. It's not gonna go to the second line, third line, fourth line. Okay. Let's say it didn't found any match. It's gonna check second, no match, it's gonna see 3, it's gonna check 4, it's gonna 5, and sequentially one after one it's gonna check and compare. Now let's say it found the match on the 50th line where it says 1.1.1 2.2.2 is a permit statement for port number 49 TCP. So that's all, it got the match. It's going to the routing information base. It's gonna see who is the right interface to go out. So there is no way it's gonna go and check for 51 52, or it's gonna go till 100 and make the decision. Okay, so it says if a match is found, no more criteria check, straight away move on, move to the next step. So if an access list is referenced by name, the access list does not exist, so all packet passes. Okay, so that says if you have something, or I can say in this way, if you have step number 1 but you don't have step number 2, so logically what does that mean? So that means that you don't have ACL, and by default everything is allowed in router and switches, right? Say for example, this is my router. Okay, and this particular point number 4, it says that you have defined, the first step is defined, but you have not done the second step, that's implementing or calling that. So basically what is happening, this is non-functional now. Okay, this to this to be functional, you have to call it somewhere. Either you have to call on the incoming or on the outgoing direction, okay, or the outbound traffic. If you don't call, keeping the access list within the router or a switch is not considered to be functional. The traffic by default are meant to be permitted, so all the traffic are getting passed. Okay, they are gonna pass the traffic without any deny. An interface with an empty access list applied to permit all traffic into the network. Okay, so basically if you have an empty interface with the wrong access list, so basically it's gonna permit all the traffic. The sixth point here says that if you have a standard access list and a extended access list, they cannot have the same name. So you cannot have the standard ACL with name HTTP block, and similar way you cannot have an extended ACL all right. Okay, so I have only 10 to 15 minutes for the ACL, so I'll just wind it up. Instead I have to take it from the start on the next day, right? So I'll just take another 10 to 15 minutes and we are good with winding. Okay, so point number 6, which says that standard and extended ACLs. Yeah, standard and extended ACLs cannot have the same name. Okay, you cannot have the same name. You need to keep a different name for different group of ACLs. So let's say you have access list. Okay, and now you're not making use of numbered. You're making use of named. So let's say
Hey, Saga.
yes.
Your screen's not being shared. We can hear you, but we can't see anything.
Oh, okay. So it's because of the latency. I have shared the screen. Uh, 1 second. How about now?
Nothing yet.
No video still. Oh. So do you guys see my screen now?
No.
Oops. Okay, so am I at least audible? In case if I'm not um s- is my screen visible now? Okay, so let's do this way. I'm gonna wind up now. Okay, so I'm not gonna cover anything, but I'm gonna upload a PDF on the web portal along with this video. So there are some assignments, or there are some practice set for ACLs. Okay, so there's a topology which you can recreate, and you can try practicing. Or if you wanna practice it on the topology which we already have for the